In the diagram below, line segment DE is parallel to line segment AB. If line segment DC is equal to 20x minus 8, line segment AD is equal to 16x, line segment CE is equal to 54, and line segment BE equals 48, find the length of line segment CD. Well, first of all, I want to label everything that is given. So they gave me that line segment DE is parallel to line segment AB. I'm going to mark parallel line segments with arrows. And then I'm going to mark the individual line segments length. So line segment DC was given to us as equal to 20x minus 8. Then line segment AD is given to us with a length of 16x. Line segment CE has a length of 54. And lastly, line segment BE has a length of 48. I want to make sure that I redraw the triangles so that I get a better sense as to how I should set up my proportion. So I'm going to first draw my small triangle right here. I'm just going to translate it right here. So I have triangle DCE redrawn, and I'm going to add back the lengths. Then I'm going to go ahead and draw my bigger triangle, triangle ABC. Then we're going to draw it right here. And when I am going to mark the length of AC, I'm not just looking at 16x or 20x minus 8. I'm looking at both of them combined. So I'm really adding 16x plus the 20x minus 8. Same thing for line segment CB. I need to now add 54 and 48 together. Okay, now I can really set up a proportion. There are, as you know, many ways to set up your ratio or your proportion, but I'm going to go with big to small. So I'm going to highlight this big to small, their corresponding sides. And then I'm going to go back to my big triangle, and I'm going to correspond that with the small triangle's side length. So what I want to do over here is to combine some like terms. So I see 16x and 20x can be combined. So I'm going to do that first before I set up any of the proportions. That gives me 36x minus 8. And also I can combine these numbers here, and that gives me 102. All right, now I think we're ready to really set up our proportion of big triangle to small triangle. And big triangle to small triangle. So here we have our big triangle, measurement of 36x minus 8. We're going to divide that with its corresponding side of 20x minus 8. And we're going to set that equal to the other two corresponding side lengths. Here we have 102. And that corresponds with the small triangles, 54. Okay, now we can cross multiply. And when we cross multiply, make sure that you are using the distributive property. So I'm going to show my work down here. I'm going to have 54 times, in parentheses, 36x minus 8. I'm going to set that equal to 102 times, in parentheses, 20x minus 8. All right, it's time to distribute here. I'm going to have 54 times 36x. That gives me 1,944x. And 54 times 8 gives me 432. On the other side, I have 102 times 20. That gives me 2,040x. And 102 times 8 gives me 816. I'm just going to combine some like terms here by bringing all of our x terms together and all of our numbers together on the other side. So what I like to do is actually keep my x term positive by subtracting 1,944 x on both sides. So we're getting rid of it on the left side, and on the right side we are going to have 96x. Keep everything else the same. Our next step is to get rid of the negative 816 on the right side by thinking about inverse operations. So we're going to add 816 on both sides. That gives us 384 on the left side. And 96x on the right side. Finally, to get our final answer, we are going to divide both sides by 96. Whatever is in front of our x term, and we get that x is equal to 4. Now remember that x is just a value. We didn't actually answer our question yet. The problem said to find the length of CD. So to find the length of CD, I need to then plug x equals 4 back into this expression over here, 20x minus 8. So let's go ahead and do our final step of plugging in x equals 4 into this expression here. That gives us 80 minus 8, which is 72. So our final answer is that line segment CD is equal to 72 units.